handling today. No, just kidding. We're going to do conflicts because you guys want to do air handling, but I want to break your hearts. So we got to look at y dot output last week for just the state machine, kind of making sense of what our parser's doing a little bit under the hood. And today we're going to be able to use it a little bit to try to find out where our conflicts are happening, and hopefully a little bit of ideas as how we can get rid of them. Has anyone had conflicts yet? Presumably you had like 36 or so in the last assignment, but for this one, if you started, you're probably seeing them as well. So if you guys remember, we did a calculator that's not in this folder. Where is it? The first or second week. And we had all this associativity, and they're arranged by precedence as well. Wow, you can't see that at all. I really hate that red. Let's try Emacs. Is that better? Say it actually looks a little bit better to me. Yeah. Let's see if we can turn off like one of the lights. Is that better? All right. So we'll try this. So this is what we did a couple weeks ago, and it was relatively simple. We had expressions, and expressions were essentially a bunch of numbers or variables added, subtracted, multiplied, divided. I think we had mod in there, and we may have added power. I don't know if we actually ended up saving that or not. Anyway, so if you remember when we, oh gosh, when we yacked it, does anyone remember how many conflicts we got? We got 0, so that was cool. But if we hadn't had these things, how much do you think? God damn. Huh?
There was a percent correct for the unary precedence.
Oh, for the precedence? Yeah, I wanted to take that out as well. So how many conflicts do we think we'll see now? Error?
30.
30 right around. I think we need to give a prize to Brian for being the most correct after the answer was shown. So this is the type of thing that we'll probably see in assignment 2, because unless my memory is completely not serving, we have expressions, and they can be added together and all these things. So this calculator that we've written, a small piece of it is pretty much in our assignment 2. So now that I've taken them away, let's try to get rid of the shift reduce. So what do I need to do? Percent left? What does that mean? Left associative. So what's left associative? Plus, minus, right? Does that look right? Now, does anyone know why I'm putting this on a different line?
Because it's higher precedence.
Higher precedence, thank you. What else do we have on here? Unary. So let's see. We had mod and unary, right? Mod's left associative as well. Hmm? We didn't do mod? Let's see. I think we did do mod right here. So it is? Sure. We can do whatever we want. We have all the power.
Put them in reverse order.
Huh?
Except put the multiplication division above plus minus.
We could do that. It would just be wrong. What else do we have? We had precedence, right, for U minus. So was that percent prec? Minus, right? Something like that. I could be wrong. I've never done this before. Let's see where our U minus is. Oh, there it is. Prec U minus. So I think we're going to be right. No.
No, I thought the percent correct was only for...
So you think it's left up here?
Well, either left or not, so it's different.
Mm-hmm. Sounds like a good plan as well. Yes, in the back.
Unary minus is like supposed to be right associative though? So that isn't like the spec for this recent project.
Sure. Okay, we can make it right associative. I don't know, like that's kind of a math question. I don't remember what precedence unary minus has, or what associativity, I'm sorry. But we can go with right. So we think that we actually put the right or the left in there, which I think sounds correct. Yeah. Yes, Brian?
By just having the prec in there, is that like saying, okay, do this in this order relative to the other things, but we don't care if it's left or right? Is that sort of what that means?
If I replaced right with prec,
Yeah.
that should give an error. Prec should be down in the rules, as I'm saying, remember this precedence. Up here you have left, right, and non-assoc, I think. I think it's shorthand for non-associative. So that's just for defining precedence.
Okay.
If you don't care about its associativity, which you may run into trouble anyway if you use that. I mean, there are times when that's useful, but if I try to say that one of these is non-associative, but I give it a precedence, I'll still get shift-reduced conflicts. I did show you guys why they're a shift-reduced conflict, right? Does everyone remember? Should I go over it really quickly again? Raise your hand very timidly, just kind of in front of your chest if I should go over it again. Okay. I'm very tempted to use this actual pen on the board. I don't know if it'll work. Dang it.
Oh, sorry.
Yeah. The disappearing TA. Okay. So the reason that we get shift-reduced conflicts if we don't have any sort of associativity is because if we have an expression plus an expression divided by an expression, right? We have no sort of associativity, no sort of precedence, right? The parser is going to get this token by token, as we're used to. It's going to see the expression, and it's happy. Right? It's going to see the plus, and it's happy. It shifts those both onto its stack. That makes sense, right? And then it's going to see the last E, and that's cool. So now it's seen a rule, or a handle. It's seen a handle, E plus E. So it could reduce this to an E, right? So maybe this turns into an E. And then it reads and it goes, okay, divided by another E. And now it will reduce that. So that's one possible parsing, one possible syntax tree for this. On the other hand, it could get to this last E here, or this middle E, and be like, well, I could reduce this, or maybe I could shift, because maybe I actually want to reduce this piece. So then it'll shift the division and the last expression, and then it decides to reduce this. And so now we have E plus E. And the last time I showed you guys this, I showed you with 3 pluses, and it didn't look like it mattered, really. It's like, well, who really cares if I do plus, which order I do it? But here we'll see that this actually does matter. So if I have 1 plus 4 divided by 2, if I divide last, it's going to make a difference. So that's why when we say something has precedence, now we're deciding, okay, you need to do this plus or this division before each other, right? You need to do them in a particular order. And by saying left and right associative, we solve the problem of that. So if we just had precedence and it was non-associative, we'd be stuck in a problem again. Because now it will read these two, it'll read this and be like, well, there's no real precedence between those two. It has no way to know whether it should reduce the first 3 tokens or shift another token on there. Does that make sense? Are there any questions on that? Okay. So that's kind of the moral of the story with these associativities and whatnot. So let's see, I suppose, how correct we were. Fingers crossed, everyone. Way to go. This is why you guys code and not me. I like it. Okay. Can anyone think of another way in which we could have solved this problem? Keep.
We could restructure the grammar.
Mm-hmm. How do we restructure the grammar? So let's say I have a grammar that is an expression, could be an expression plus an expression, or maybe it's an expression times an expression. And let's say an ID, but we'll more or less ignore the ID because I don't feel like reducing those down. So if we want to restructure this, what do we have to do? Keith.
To maintain the precedence, we can make a separate term for like a term.
Mm-hmm.
So it'll handle the multiplication.
Mm-hmm. So we'd have, so I could run through all of this with you guys, but it's in every single compiler's textbook and every compiler's website you'll look online. So I just want to give you the idea of it. Right? It's just like Keith said, we'll switch it to be something like, well, an expression, this pen is so gross. All right. Could be maybe, was it like an expression plus a term maybe? Or I think it's expression term, something like this. Forgive me for being wrong. And then a term is something like a plus a t prime. And so now we've said, well, now the associativity is on the left. And we'll go down like this and continue restructuring. If you guys want to see how the whole grammar looks, drop by during my 4 hours of office hours today. I get lonely. But anyway, so it is possible to restructure grammar. I don't want to show you that one because that one's boring. I have another version of a restructured grammar that I want to show you guys. Yes, Brian?
Can you run that code and try it with 2 minuses in a row? Because the way that's written, I think that'll work as a plus, but I'm not positive.
Like that?
Yeah. Sweet. Okay. I was just trying to make sure I understood.
We're the best. Well done, everyone. I take no credit for that. So I have artificially created some grammar that's going to take a series of identifiers. So this is actually going to touch on error handling for people who are interested in that, which is fun. But I want this grammar to accept things like, we'll say an identifier is a character sequence with no spaces in it. Thank you. You want to toss it? All right. I'm so good. Thank you. OK, so we want to say, oh, it's so pretty. I love it. OK, A, B, C. That's good. Those are 3 identifiers, right? But we want to say maybe A, B, C is bad. We want to say, well, you have an extra comma. And we don't just want to say syntax error on line 1, right? Because that was lovely for, you know, an HTML toy project. But at this point, if you just tell me there's a syntax error on a line, I'm going to be kind of sad, right? Because maybe I write all of my code on 1 line, and it's not going to be very helpful. Hmm?
I would be kind of sad.
Yeah, well, you don't see my code. You're my parser. So Okay, so we want to say this is bad, and then we want to be able to report some sort of meaningful error messages. So just to quickly look at the Lex, as all my Lex files are in these toy projects I give you guys. It's really simple. y.tab.h, we're used to that. Any character string with no spaces in it, that's all the letters, is just an ID. A new line, I just wanted to have an end character so that it won't syntax error when you put a new line at the end of it. And that way I don't have to feed it files every time. I can actually type in the terminal for you guys to see. And then I want to return a comma in the event that I see a comma. Anything else is not really going to be accepted by a grammar anyway. So it's not very robust. That's okay. So we have our boring include statements that we're pretty used to. I have 3 tokens. We saw them in our Lex. I have a start symbol that I artificially created just for simplicity's sake. So the start symbol is a list of, the list is for a list of identifiers, and then it ends, right? And then I say, okay, so a list could be an ID, right? That'd be all right if you just had one ID. Or it could be a list, and then a comma, and then an ID. That would be good. And I say this opt comma, that's optional. It's not actually optional, right? We don't want it to work without the comma. We don't want there to be some random token in between here, right? So we say that a comma, or an optional comma, could be a comma, which would be good, or let's say it's nothing, right? And then we say, oh, well, you missed a comma, right? And then we could also say a list is a list that ends with a comma, right? And say, well, you had an extra comma at the end, but we discarded it, maybe. So this is theoretically doing some sort of code generation, right? But we don't care about that till like week 10, so we're not going to do that. Yes, Brian?
Don't you have to do YY error okay for it to continue after that? Something like that?
He asked if we have to use YY error OK to continue after we've seen an error. I guess I misspoke a little bit. You don't need to. Your parser can recover without calling YY error OK, as long as it sees 3 valid tokens in a row that it can correctly shift and reduce right after the error. YY error OK tells it that, you know what, you don't need to find 3 correct tokens now. You can just go back to parsing. The reason there's no YY error OK here is because I don't care about it recovering. I want it to crash. This isn't a full project. This is just, I just want to show you guys what happens. So, does anyone see any problems with this? Does this seem okay? It makes some sort of intuitive sense, presumably. But since I'm showing it to you at 9:20 on the day about conflicts, it's probably not going to work, right? So let's see what happens. I'm going to use the -v flag to get y.output in case we're interested in looking at it, which we will be. So that's bad. So what has happened? Does anyone know what's happened without looking at y.output? Keith does, so I'm not going to call on him, because that's boring.
I have an idea.
Okay.
The rule that allows the comma to be nothing,
Uh-huh.
it throws an error when it does that, and then when it gets to a comma, it'll always throw an error because it can technically do nothing. So.
Uh-huh. So he's saying that maybe since the optional comma could be nothing, every time it sees a comma, it's going to try the nothing rule, and it's going to give us errors, right? All those epsilon reductions. So that's possible. Do you guys want to see how it behaves? Absolutely.
Could it be because you have list opt comma and right underneath you have list comma, so when it sees a comma, it's gonna be like, well, I can go
Well, essentially what's happened is we have a conflict in the worst sense of the word, right? So list op comma or list comma, when it sees a comma, we have a really intense conflict. Do we want to reduce and get an opt comma here out of epsilon, right? We could do that for free. Or do we want to shift this comma? And then let's say we shifted that comma. Do we want to reduce it to an opt comma, or do we want to parse this error? So we've got a pretty broken grammar. So we could look at y.output, and we'll see something kind of interesting. So in state 6, there's a conflict for reduce, reduce. And it says that there's a useless rule, opt comma turns into a comma. So these should be glaring red lights that say something severely wrong, right? So we go down to, let's say, state 6. And we see something kind of interesting. We have something with brackets around it. Does anyone want to take a guess what those brackets might mean?
A reference to a useless rule?
Perfect. That's never going to happen. So it's never going to reduce using rule 5. Does anyone remember off the top of their head what rule 5 was? Can't believe you guys didn't memorize my grammar. There it is. Good. So it's if it sees a comma, it'll reduce that to opt comma. So this may look familiar, right? This dot means this is where we are in the rule that we are expecting, right? So we've seen a comma, and we've presumably seen the list before that, right? So we could reduce this list comma to an error, or we could reduce this comma to an opt comma. So now we know that there is a conflict. We know what kind of conflict it is. It's a reduce, reduce. We know one of them is never going to happen. Does anyone know why this one in particular will never happen?
Because if it wasn't comma, it would match the other rule.
What do you mean it would match the other rule? Why? That's what I'm saying.
Oh.
Is it because it'll take the longest match?
It's a good guess. Not quite what I'm looking for. So he said it's because it's a longer match. Does anyone know what Yak does in the event that it has a conflict? It has default actions, right? So if it sees a shift-reduce conflict, it'll shift. If it has a reduce-reduce conflict, well, I could ask you what it's going to do, and you could say reduce. We could laugh, right? But of those two reduces, what will it do? Keith?
One is textually first in the file.
Yes. So in the event of a reduce-reduce conflict, it's always going to go with the first one that you wrote down. So that's why that last one, rule 5, is never going to happen. So we could, I don't know why I keep changing text editors.
Probably because you guys better, but you know, it shows up better.
Yep, something like that. All right, so I said to myself, that's bad. Commas is bad. It's not going to work, right? Not going to work anything like we intended, and it looks like it's going to error no matter what you give it, except maybe in the event that you just give it a single identifier. But that kind of defeats the purpose of our entire grammar. So let's try to restructure, and we rebuild. And I've tried something else with slightly different. All right. So a lot of this looks the same, right? A start symbol is a list followed by the new line. A list could be an ID, or it could be a list and then a comma and an ID, which would be good. That's what we're looking for, right? And then it could be just a list and then an ID, which would be bad because we've missed the comma, right? Or it could be a list and then a comma, which means we have a trailing comma at the end. So how does this look? Better?
There's still a conflict,
kind of a conflict would that be if there was one? Shift reduce. Good. So what's going to happen, the end of this story, is I'm going to yak it with dash D and dash V again, right? And it's going to say shift reduce conflict on these rules, right? Because it's going to have a dot at this point, right, after the comma in both rules. So be like, do I reduce this down to a list, or do I shift the ID on and then reduce it from there? So that's perfect. It's a shift reduce conflict. So our wonderful attempt to fix our grammar didn't. We went from a reduce reduce to a shift reduce. So hooray, right? So let's just look at it real quick to make sure I'm not lying. Shift reduce conflict. So we could look at y.output again. It says, okay, there's a conflict in state 7. Shift reduce. Pretty much like we expected. So we go down to 7. And this hopefully is somewhat similar to what I said, right? We've seen list, we've seen comma, and now we don't really know whether to reduce or to shift. So we may see that there is another bracket, right? That's the useless rule again. So it's never going to have an ID in this state, right? Because it's never going to shift that ID on the stack. I'm sorry. It's never going to reduce it down. It's always going to shift. Sorry, that's the reduce rule. Does that make sense? So, right, exactly. I'm sorry. So I misspoke. I did. So it will shift, which is why this is going to happen. This thing's not in a bracket, right? This is the shift rule, right? And this is the reduce rule. The reduce rule is in the bracket because it's never going to happen. The default action for yak is to shift in the event of a shift-reduce conflict. So now that I have lied to you once and then hopefully told the truth. Let's see. Will it cause the desired behavior? Let's find out. I don't really want to act like I know what's going to happen, because that'd be silly.
Wait, was that
The Lex file stayed the same. So what do we want to try? Like that? That goes well. I didn't give any like congratulations messages like I did last week. So it does work. But that doesn't mean that it's perfect, right? So we happen to get the behavior we were looking for. This is a lot like the dangling else problem, where the conflict is bad, but it's not awful, right? Because the action to shift rather than reduce is acceptable. But let's say that we want to fix it anyway. Let's say we want it to be really specific, and we're not happy with a shift-reduce conflict that happens to work. Because even in the dangling else problem, you can solve that. It's not an unsolvable problem. It's just really ugly. So let's try to take a step back and restructure our grammar again, hopefully for the last time, right? And try to think of kind of what we're looking for. So when we think about the input that we want if we have, so at the beginning, we don't want there to be any commas, right? We don't want them to start with a comma. That's silly, right? And then we want some sort of, a list, maybe followed by no more commas. So that's actually just thinking of it in that way can kind of lead us down the right direction. Just be like, well, we don't want commas at the beginning, and we don't want commas at the end, but we want to do something if we happen to see them, right? So it looks pretty similar again. But now a list has no commas, and then there's an ID list, followed by some more non-commas, right? No commas here could be nothing, which would be good, right? In that case, we don't want to do anything, right? But let's say no commas reduces to commas instead. And commas ends up reducing to a comma. But if it has commas in it, rather than the no commas that we wanted, we're going to give some errors, right? And then commas, we really only want there to be one. We don't want to see a bunch of commas in a row. But we could theoretically see more than one. So in the event that we did, right, we do the same recursive. This is left or right recursive, however you want to say it. The recursive token's on the left, though, right? Or non-terminal, I'm sorry, the recursive non-terminal token's on the right. We want to say that you had an extra comma, and we discarded it. And then an ID list should be either an ID or an ID list, and then just one comma, and then an ID. So the just one comma is, again, it could be multiple commas, right, which would be you have the comma, which is good, or you have multiple commas, which is bad. Or let's say your one comma doesn't give anything. We want to say that you missed a comma. So what do you guys think about this one? It might actually work, which is, I think, a little pessimistic, given that our last one also worked. But that's okay. Someone doesn't believe in me. What else do you guys think? Does anyone think there will be conflicts?
It just seems kind of like elaborate to do something so simple.
Mm-hmm.
I think there should definitely be a cleaner way.
Very well could be. So let's say that we think that maybe it'll work. We don't sound particularly confident, but that's okay. But we think that maybe there's easier ways of doing it. So let's try to yak it. Drum roll, and yes. So maybe Brian's right. Maybe it is correct, but elaborate. That's why I decided to do it. I'm not even close to willing to say that it's the only way to do it. There is no commas for. We could build one if you guys like. Yes? Yeah. The difference is where the errors are, actually. So if I have one comma, right, commas is good. But if I have nothing, it's bad, right? And then no commas. If I see a comma, it's bad. So these titles here, the non-terminal names I've chosen to use, aren't necessarily what I will see, but what I want to see. So they each have an error rule for, well, what if this wasn't what I wanted it to be? It's one way to do error handling. There are many. I'd love to stand up here and tell you that, hey, so this is the way to do errors, just follow this algorithm, and you'll be done with the project by the end of tonight. That's not going to happen. Not particularly close, even. You got to read about error handling in Yak. You got to mess around with it. You got to play around during the weekend and whatnot. There's really no way around that. I'd be happy to help you, but I can't just like show you the definitive way to do error handling, because every time I do it, I have to refigure it out anyway. So we can see this guy run quickly. Thank you. I don't want to type it. Sweet. Hooray, A, B, C, and then we should see A, B, C, comma, not work. And now we have the added functionality of, it'll tell us. Which one? So we have a little more of a robust program now, and that's cool. I have another example to show you guys kind of as I build it, unless you'd like to kind of ask questions and veer this in the direction that'll be helpful to you now. So a space should be strange. Because I remember the huh? Oh, B. Oh, whoa. Mm-hmm. Right, so it outputs the space.
Oh, okay.
Right, the Lex does, because I didn't give it any rules for space because I'm very, very lazy. Thus, computer science. But it knows that we're missing a comma because now A and B aren't one token of an identifier. Now they're two, right? So, I mean, we could have done the exact same thing with A1, right? I'm going to say the same thing, except now we get a 1 instead of a space. What else would you guys like to see? Dana?
I have a question.
Mm-hmm.
It's not about errors.
Is it about conflicts? Is it about yak? Is it about compilers?
It's about flex. It's about definition. Maybe I could ask you.
Hit me.
Okay. You know how we define things like I'm defining commas maybe in flex, and I have a big long regular expression.
Mm-hmm.
So I can look for it later, and I forget it says curly brackets.
Yes.
To look for it.
Uh-huh.
Is there a way to define C in terms of A? So like I define comma, and then I want to define something else to say not comma. It's a stupid question, but it has come up for me, and I can't figure out. Because it's not array. I mean, I can't split them.
So if you wanted to use the not, so I think you can use your previous definitions and future definitions. I don't think there's any issue with that. If there happens to be, I'm sorry, but you can still, you don't need those definitions, right? They don't give you any power. So you could just rewrite the regular expression in subsequent rules.
I just feel like that's weak.
I'm pretty sure you can use definitions. Have you used it? Okay. So minus. I mean, you need to do the curly still, right? And then if you're looking for it's essentially set operation at that point, right? You say I have the set of things, and I want to, except for these things, use the minus. Yes, Brian.
I think this would be easier if you just make an example. It's one of the things you can explain all day, and it still doesn't make sense unless you have an example.
All right.
Take print and subtract numbers or something.
Anyway, thank you.
You're welcome. So, I mean, I don't know syntax exactly, but let's say that I have stuff could be A through Z, or 0 through 9. Okay. Star.
Okay.
Why are we laughing? Don't laugh at me. I'm watching you. All right. And then we want to say no numbers or something. Could be stuff minus 0 through 9. Okay. In its own set of curly braces?
Yes.
Okay.
Yeah, that should work.
So that would be, we've used stuff, and we want to say, okay, well, too lazy to define A through Z again, so I'd rather write this longer thing. I'm ridiculous. But this is a theoretical example that I came up with in less than a couple seconds, so all right. And it's all ugly and purple because I used Vim. So does this make sense? It's essentially set operation for everyone who's taken some sort of discrete mathematics. Okay. I've never used plus. I don't know if it's defined. I think it's probably not, but don't hold me to that. Right, because right, we're essentially doing the plus with the lowercase and then the uppercase just by putting them all in, right?